We're going to be talking about the constant of proportionality with the 6+ students. Let's look at the definition. The definition is the constant value of the ratio of proportional quantities. What does that mean? It also is classified as the unit rate, and we've talked about that in ratios. You can identify the constant of proportionality in tables, graphs, and equation, and other proportional reasoning. We are going to be talking about and giving examples of those three today. Recall how to compute the unit rate. Use those same strategies to find the constant of proportionality. For example, when I'm talking about unit rate, I'm talking about how much does one cost of each. So I'm going to be looking for X to be 1 or how much one item costs. We're first going to look at tables. Here I've got a table that says the number of pens, which is P, and then it gives me 3, 5, 8, 10, 15, and the cost. So 3 pens will cost $6, 5 will cost 10, 8 will cost 16, 10 will cost 20, and 15 will cost 30. If you notice, what is the cost of 1 pen? That's what we need to find out. The cost of 1 pen is going to be $2 because I'm going to divide the number of pens into the amount of money I have. So if I've got 3 pens, I know that they each cost $2 a piece. Because it's $2, the constant of probability is going to be the actual 2. So the 2 is what is going to be the constant value of the ratio between the number of pens and the cost of the pens. We can write an equation as C, the cost is going to equal to 2P. The cost is equal, the big C is equal to the total cost equals to $2 times every number of pens that I want to buy. So 2 would be the constant of probability here. Proportionality, I'm sorry. The second thing we're going to do is we're going to look at some graphs. We can also look at a graph to see what the constant of proportionality is. Number 1, to determine the constant of proportionality, find the unit rate. That means how much does one cost. So to find the unit rate here, I'm going to look at the length down here on the bottom, and I'm going to look at 1. And I'm going to come up here to 1, and where y is equal to 4, I know that what the length of the lateral area is when the length is 1 is going to be 4. So 4 is going to be my constant of proportionality. The ratios from here would be 1 to 4, 2 to 8, 3 to 12, where they're going to meet here, 4 to 16. The next one would be 20, so it would be 5 to 20, and so on. So I know that the ratios are going to be up, and they're going to have for every fourth one. If you see 1 is 4, 2 is 8, and so on, I'm multiplying by 4. The equation for this graph would be A equals the area, or the area of the lateral surface area, is going to equal to 4 times whatever my length is. The area equals 4 times the length, so 4 here we know is going to be the constant of proportionality. We can also look at them when we're looking at equations. Here I've got a word problem. It says, since we know that, or an example, since we know that proportionality equations are only using multiplication and division, we're going to use the coefficient, and this is the big word here, the coefficient, okay, to identify the constant proportionality. For example, what we mean by multiplication and division, when we talked about x over 12 is the same thing as 3 over 24, okay? We're going to look at this and say, okay, what can it be? Or here I would say 24 and 12, okay? I would have to cross multiply, so I'm using multiplication to say 12x is equal to, and then we're going to say 3 times 24, and that's going to give me 72. So I know that I'm multiplying or dividing out, and I'm trying to find, I'm multiplying and dividing by 12. So that's what we're talking about when we're saying the multiplication and division. That we're only going to use those. We don't ever add or subtract when we're talking about proportionality, proportions. So the amount of the sales tax paid on an item is proportional to the cost of the item. If the sales tax is 7%, then the amount of the sales tax is going to be T is 0.07. I have changed the 7% into a decimal by moving it 2 places to the left, and I'm going to multiply it times the cost of the item that I'm buying. The equation that we can set up would be T is going to equal to whatever 0.07 times the C is going to be. And it can determine the amount of the sales tax. This will tell me how much it's going to cost. So my tax is going to equal to whatever 0.07 is times however much the items are going to cost totaled together. So the constant is going to be my 0.07, or you could say 7% if you wanted to, since that is the coefficient of the equation. We're going to be doing a lot of these in class, or a few of these, and you will find that's very easy to find. Remember, when we're talking about graphs, we're talking about finding the one. We're always just looking for what does one cost. When I'm at a table, I can look at the table and decide how much is one item cost. And here I'm looking at equations, and I can say, look for the coefficient here. And that coefficient, remember, as we talked about in Unit 1, is the number in front of a number and a letter that you're multiplying together. So we're going to do these tomorrow in class, and I'll see you then.